Okay, see Lindelof videos. Find trigonometry. Find the inverse of 3 sine of the quantity 2x plus 1. So here we have 2x plus 1 is the argument, right? First thing I'm going to do here is what I always do, and I've said this a million times, but I'm just going to trade in my f of x and call it y. It just makes it a lot cleaner. So y is equal to 3 sine of the quantity 2x plus 1. Remember, anything that's in the parentheses is part of the argument. So having the parentheses moved here would mean something totally different. So please keep that in mind. I'm going to start pursuing this. I'm going to divide both sides by 3 to get rid of this. This is 3 times that value. So it's y thirds is equal to sine of 2x plus 1. So from here it looks pretty good. Now what I want to do actually is I want to switch these things, and I want to declare that I'm taking the inverse. So I'm going to say that I am doing that, and I am going to say that 2x plus 1, I'm switching the domain and range, right, is equal to the inverse sine of y thirds. You notice I have not switched x and y yet. I could do that, but I just haven't done it yet. But I want to make clear that I do realize I haven't done that. I'm going to add positive 1 to both sides. I'm sorry, negative 1 to both sides to get rid of this 1. So I'll get 2x is equal to the inverse sine of y over 3. Remember, I'm going to subtract this 1 so it's there, right? And then I'm going to multiply by 1/2 to get rid of this. So I'm going to multiply this by the reciprocal, right? Just so you know, this is that. So I'm going to multiply by its reciprocal, right? So I'm finally going to get x is equal to, I'm just going to write it like this if you don't mind, 1/2 times this quantity, the inverse sine of y thirds minus 1, because the whole thing would have to be multiplied by that 1/2, wouldn't it? And then finally I'll switch x and y. So finally I'm going to switch my x and y base. So y was here, I'll put x here, and x was here, I'll put a y here. And last but not least, I will declare that I have actually taken the inverse of this. Alright, and I'd have to declare what interval I'm taking this over to make this function invertible, so I haven't done that, but I'm just trying to show you just the operational way to take this inverse. Hope it was helpful. If you haven't already subscribed, please do, and your comments are always welcome. Thanks.